Hello everyone, Vladimir is here with our multi-platform game development tutorial lesson 6. So in the previous lesson we have introduced the way for our character to move around and well, what's the point of walking if there's nowhere you can go? Or rather, what's the point of walking if there's no incentive to walk anywhere or to dodge the attacks in particular? So today we're going to start working on this attack dodge mechanism when the enemy is going to attack part of our field and the player will have to dodge the attacks. To do this, we will have to display the warning indicator at the tiles, and if the player stays at those tiles, he will get damaged. And if he takes enough damage, he loses the game. So the idea is simple. We're going to implement this warning effect that is going to show above the base today. And without further ado, let me switch to editor. Let me just load the proper project right now. And here we are. So first thing first, we need some kind of an engine that will display the effect in the field. But it would be much better if the engine would be universal for all the effects. For example, if we'll add the floating numbers that indicate the damage, or if we add the attack animation itself on a tile, or something like that. So I think the good idea would be to start a new package, say in graph. Let's call it effect. And inside the effects package, we'll create the effect engine class. For now, I'm just going to add the blank constructor here. Effect engine, don't confuse it. Nothing happens. But, well, the engine will need to work with effects. So let's start with adding the effect first. In the same effects package, add the effect class. Right, so let me add the public constructor effect. Brief introduction. When we are working with the objects in game development, especially if the objects are going to recur lots of times, and especially if we're touching the mobile platform, it is very important not to reinitialize the objects in terms of memory, but use the existing ones and initialize the variables there instead of allocating the whole memory block for the object again. So this effect class can already be handled by the functionality of Libgdx. Libgdx offers us the pooling, we can make it implement the poolable interface. And the class is actually going to be abstract. We're not going to initialize the effects anywhere. We're just going to initialize the children. So the pool is essentially a memory, a collection of objects where the effect, in our case, the effects. So the effects will have some properties, and those properties will simply be needed to reinitialize. For example, when the effect disappears, we're not deleting it from the memory. We're keeping it there. We're not showing it in any way, but we're just waiting until the time when it will be available and necessary again. So that would be meaning the reuse of memory. Right now, it should not worry you, but let's focus on what every effect will have. So I think every effect is going to have the boolean of is alive, indicating whether this effect is alive. If effect is dead, then the effect engine is not going to work with it, and it will remove the effect from the list and mark it as available for reuse. And it's a good idea in our case to count the time in which the effect has been alive. So it's time alive. After that, we are going to, assign the basic variables here. IsAlive is false and timeAlive is 0. And I think it's a good idea if we already introduce the public void init class. So idea is simple. We run constructor only once, but it essentially does nothing. And then when we actually want to use the class, we run the init method that will do all the necessary initialization or reassignment of variables. So in init class, I'm just going to write that, the object is alive and the time alive. Wrong parameter name. And the time alive has been 0. That would ensure that on every restart, on every reinitialization of the effect, we're getting the 0 state object, as I like to call it. And the same thing, and for the effects, we'll need the update function, which will, update the state of effects according to how much time has been spent. In this particular case, we're just simply updating the time alive variable. We're just adding the time that has passed, and we'll be able to check against it. And we'll also need the draw function, which will be responsible for drawing the effect. So sprite batch, and let's make it abstract. We're never going to draw the simple effect. We're going to draw only the derived effects. Regarding this, I also think that we might need the method which will say whether the effect is alive, the simple getter. And let's make the init function lowercase, just so it would be in the same style as others. So public boolean is alive, which will essentially return is alive result. We can technically get rid of is alive, and we can override is alive function in the upcoming derived classes, but I'm kind of used to this way. Feel free to argument why it's a terrible idea, apart from the 4 bytes that go to the boolean variable. I think our effect is somewhat done, and after this I think we need to get back to the engine. Oh, we also need to pass, the effect engine parameter, and this will be used when we will want to add the effect to our engine. Of course, our effect engine still does not have the add function. Let's add it. Effect engine essentially contains the list of effects. On every program update, it goes through the list, updates the effects, all of them, and also draws them, the separate function. And after the effect engine finds that one of its effects is expired, he removes it from the list. So it's that simple. Basically, let's make the list of effects. We'll call it effects, or I think it's okay. Let's just import the class from Java util, I think. In this case, we need to import it from the util actually. And in the constructor, just create the new array list effect. You know what happens if we use the Libgdx list? Let me just check it. Let me check it if Libgdx makes a difference. Import class list, and then we use the array list. Nope. Never mind. The list is responsible for UI. In this case, we're importing the Java util list, and the same way Java util array list. And after that, let's implement the functions that I have been talking about. This will be, the first one will be the add function, which we already calling, but which is not there. Add effect, and let's make sure that our list of effects is actually adding the effect to it. So it's the simplest one. It just adds the effect. That's all. Nothing more, nothing less. Nice and simple, but we need to move to more complicated stuff. First, let's get to the update function. We'll pass the delta, the time that has already passed since the previous action. Let's declare the variable I, which will be the counter, the index that is going to be used when we go through the whole effect list. The idea is to go through the whole effects list, call the update function of every effect, and if the effect has expired, remove it from the list. While e is lesser than size of our effect, we run the effects get update. We simply call the child's update for every effect that's there. And after that, if the effect is alive, we move forward by increasing the index. So we go ahead for the next effect. But if this is not the case and our effect has actually expired, it's a good idea to release it. Wait. I think we should need to... Yeah, let's make the separate release function, which will be responsible of, you know, of releasing some extra things if we use them in effect. Let's just release, and apart from that, we also need to delete this index. We also need to delete this effect from the list. So effects remove and pass the index. We don't increase the index here because after we have removed the effect, the further effects move to the left. And on our current spot there will be a next effect, unless it's the end of the list, which is handled in the while cycle already. So after that, let's get to the draw function, which will be won't be very complicated. Sprite batch, we pass the batch, it goes through the whole list of our effects. Effect size. And it calls draw and passes the batch. So it's that simple. Another thing that we should probably add is the clear function. That will be clearing our list of events and letting the memory pool know that those effects can be reused. For example, when we will have any other screens and we leave the game screen, we'll just be telling that, okay, we can get rid of the effects and put them back into the pool, or get rid of them completely. Public void clear. We will public because we want to call it from any part of the code where we have access to effect engine. And while effect size is greater than 0, we're just going to release and not reset. A reset is the special function that is called by pool when the object is you know, returned to the pool. We don't really need to reinitialize anything in those objects, so I'm not using the reset right now. And we also need to remove the 0 indexed element. So the clear function basically clears our list of effects. After that, I think it's a good idea if we start implementing our warning effect. So let me open paint.net, make a new file which is 16 by 16, clear it so there will be a transparent background. Let me try to draw some exclamation sign. I'm sorry, I'm not an artist. In the middle of it. Is it a middle? Not really. So I'm just drawing the point. Let me draw the thin line. So basically it's a warning sign. Not a warning sign, exclamation sign. But let's make a good background first, or at least yellow background. I didn't mean good background, I just mean yellow background. I hate yellow backgrounds. But it will be more visible that way, I think. Okay, let me see. It's going on nicely. I'm just covering the whole painting with this stuff. I should use the thin lines, but you know, I'm in a bit of a rush right now. Don't want to take too much of your time. I don't think it's very entertaining to look how I'm drawing. But yeah, let me just move it a bit to the left. This is how the exclamation sign is going to look like. Let me flood it with our color, and let's actually save it in our Dodging Hero assets folder. Let's call it a warning. Cool, warning sign. So okay, this one is done. This one is done, and let us create the actual warning effect class, which will be derived from the effect class. Warning effect, which extends the effect class. Press Alt Enter. Android Studio will offer you to implement the methods that are missing, which is good. I'm just going to add a constructor here, warning effect, that does nothing. And we will also need the custom initialization function like public init, which will require, you know, field x, field y. This is the coordinates of our base, and x and fy, the size evaluator, because we're going to draw the sign on the specific coordinates. And apart from the size evaluator, we also need the resources, so they will show what needs to be drawn. So resources, I'll call it the rest. And the thing is, the tricky part starts here, because it is often, you know, if we're using the pool, each type of the object needs to have the separate pool. So the same thing goes for the warning effect. Since, you know, this is the inner thingy mostly, I like to do it as the inner thing. I'm going to declare the static pool warning effect, which will contain the warning effect. Let me automatically import class from Gdx utils, and let's name it warning effect pool. Wow, it's a good name, but I'd rather call it warning pool. And after that, we just call the initializer. So static means it will be 1 for the whole class. You don't need to initialize the object of the class. This will be the universal variable that is accessible from every object. And this warning pool, we need to implement the function which is responsible for returning new objects. In this case, is really simple. We just press return new warning effect. And to actually access this pool, I don't want to access it from anywhere outside. I'm going to, first thing first, we need to change. We're going to need to go back to the effect and rename the function to release, so it's not utterly embarrassing to call release, and here in warning effect release. So first thing first, in the release method we need to let our warning pool know that this particular instance is free to be reused. And public void init. And in our init function, we will need to assign 4 new variables. Let's declare those variables here in the warning effect. Always make it a habit to declare variables at the start of your class. So that way the readability increases, you always can look something up and understand what's going on. So we will need the private field x, field y, size evaluator that points to the size evaluator that we have passed, and let's rename it in the init function so there will be no confusion. And we also need some pointer to resources, and the init simply assigns those values. size evaluator as z, resources equals res. The thing is, how I go around hiding this warning pool from the main program is that I use the create function. I create the public static create function, which returns the warning effect. And here's what I do. Warning effect is like warning pool obtain. I obtain the new object. I also need to pass the parameters to this function, which will be used for the object initialization. So effects init effects fy as 0 as basically I just pass the resources further, and then I return our effect. So the only thing left is I actually need to override the update function. We need to let the program know that the warning effect has ended. Float delta. We call the super function, meaning that we call the parent function update. Our effects update function increases the time alive, so definitely do not miss this thing. Do not miss the update call in the warning effect. And you know what? Let's show warning for 2 seconds, then the warning is done, and then there will be damage to the player. At least that's the plan. So we can compare time alive is less than, create a new constant like warning lifetime, call it like this, or I have it called, I usually, in my documents, yeah, I'm just calling it warning time. I'm just creating a constant field at the top of the file. I'm letting it to 2 seconds. That's the easy part. And let's take care of the draw function. Not first. Like, if our time alive is greater or than warning time, is if the object, if our warning has been alive for 2 seconds, actually it becomes dead. It expires. That's what is going to happen right now. And we've done that. We need to take care of the draw. To take care of the draw, we need the access to our warning picture. To do this, we get back to the resources. We declare another texture region here called warning. And warning equals game sprites find region warning. It's as simple as the previous declarations of the game sprite. We just looked up the warning from our assets, and here we begin by batch, and for every begin there should be an end. This is what I write first, and then we actually draw. We pass the resources warning, and then we use our size evaluator to tell us the coordinates. So it should be field x and size evaluator get base screen y from field y. It looks like the warning effect class is done. At least I think I've implemented everything that I wanted to. Now we just need to update the game logic and game screen, and we'll be able to monitor our effects of our changes. So let's go to effect engine, because it says there's an error. Fixed it. So we're going to game logic. Let's go back to game logic. We need to introduce the effect engine here. Let's call it effect engine, of course. Initialize it at the whenever we construct the logic. New effect engine. We will need an update function called from the logic, which will call all the relevant game logic updates. So it's a good time to make it. Public void update. We're passing the float delta value, which is going to be used in the further update values. And the first candidate for an update is effect engine. So it's that simple. But the thing is, our game screen also needs to draw the effects. And to draw them, we still need to use the effect engine. So the logic should have a way to return the effect engine to our game screen. To do this, we're just declaring a new function, get effect engine. And let us just simply return in our game screen, we need to get down to business. Let's just call, in first thing first, update function of our game screen. This is our game screen class. We need to update the logic too. Logic update, pass the delta, forget about it. And apart from this, we also need to, to draw the effects. So we just try logic after draw bases function. When our bases are drawn, we just get effect engine and we call the draw function and pass our awesome sprite batch. If we run the game now, nothing changes, but the lesson is getting a bit lengthy and I really don't want you to just go away and see nothing. So for now, again, as a temporary measure, when our in our constructor of game screen, let's just quickly call the warning effect create 0, 0, pass it to tile 0, pass our size evaluator, and pass our game resources. So after this, whenever you run the game, you should be able to see for the first 2 seconds. Well, you should be able, but you're not seeing it. The exclamation sign on the left corner. So, as usual, let's see what's going wrong. The warning effect is drawing the resources, warning. It is initialized properly. The effect engine calls the draw properly. Let's see if the effect engine actually calls the draw. System out print line, and we just call drawing effect. Should be a piece of cake, but it's not always a piece of cake. So okay, I already see that there are no draws going on. That's the first thing first. That's the first thing that should be concerning. To do this, I probably am not adding anything to the list. And you see, here's the thing. In our warning effect, when I call the init function, I have not called the parent's initialization function, where I should pass the effect engine. So as our third parameter for consistency, let's add effect engine parent and pass this parent thing inside of the init function. The same thing we need to adjust is our create function. Add the effect engine here and pass the engine in our init. And now in our game screen, we need to pass our logic get effect engine. Let's see if something changes. See, we have our warning sign and it disappears properly. So for now on, I consider that our initial thing with the resources is, well, done. I'm going to continue this in our next lesson. It will be much faster and it will be much more easier to implement this kind of effect right now, so we're thinking long term. Let me just commit the changes as usual. Let me open my file. Let me go to the Dodging Hero folder. Let me check git status. Let me add the assets folder. We've changed quite a lot, and let's commit the changes. My message is introducing the warning sign that is used on the base before attack. After this, we're just pushing the results to our origin master. So the changes are committing, and I wanted to say that in the next lesson we're probably going to make this warning system much more systematic. We're trying to add the health to the player. If he gets hit a lot, we're just, start telling that the game is done. Probably by quitting it at first. So thank you for watching. I'll see you in the next time. Vladimir is out. Cheers!